Alright, for section 9.6 we start to get into permutations, which eventually is going to lead us to probability. But 4 problems to kind of help you out with your homework if you need it. And first one's going to be, how many different orders can 4 girls and 4 boys walk through a doorway single file if there are no restrictions, or if the girls walk through first and then the boys follow. Second one's going to ask you to find the number of distinguishable permutations there are for the letters in the word statistics. And what that's saying is I can rearrange those letters to make a new word, but the word doesn't have to make sense. So how many different new words can I make? And the third one's a kind of a story problem. It says we have a toy manufacturer, 8 people are applying for jobs, 3 of the 8 are women, so 5 of them are men. If all 8 are qualified, how many ways can the employer fill the 4 positions if they select completely random, and if they select 2 women, implying they're selecting 2 men? And then the last one's solving an equation where you have permutations in them. Alright, so let's go ahead and take a look at the first one. In how many orders can 4 boys and 4 girls walk through a doorway if there are no restrictions? So you need to ask yourself, how many kids do you have, or how many people are there? And of course we have 8 total. And how many are going to walk through the doorway? All 8 of them are. And then you need to ask yourself, does the order matter? Now I know we're in the permutation section, so it's pretty obvious that we need a permutation. But you would need to ask yourself that question on the test. Does the order make a difference? If I walk through the door first and then you follow me, is that different than if you walk through the door and I follow you? And the answer is yes, that is. So I know it's a permutation. So it's 8p8. Or a lot of times we do, when we're doing stuff like this, people walking through a doorway, do the little slash idea. 8 could walk through, then 7 could follow. There are 6 people left to follow those 2, 5, 4, 3, all the way down to 1. And that is the same thing as 8 factorial. If you use the formula, you would say it's 8 factorial divided by 8 minus 8 factorial, which is 8 factorial over 0 factorial, and then by definition 0 factorial is 1, so it's really just 8 factorial. And so you can take out your calculator if you don't know that off the top of your head, and I don't. And you can either multiply them all out, or if you remember to hit 8, go to Math, over to PRB, and that will help you find the factorial button. Or you can use the NPR button and do 8p8, however you want to do this. So here's 8 factorial. If I had used the permutation button, going through the same thing, going to Math and then over to PRB, and I had picked number 2, 8p8, you see it's the same thing. So that says that there are 40,320 ways for the 4 boys and 4 girls to walk through the door, if there's no restrictions. Now, if we want the girls to walk through first, there are 4 girls and we want all... There are 4 girls and we need all 4 of those to walk through first. So there are any one of 4 girls could walk through the doorway first. Then one of 3 is going to follow that person. Then after the first 2 girls go through, there are still 2 left. And then after the first 3 girls go through, there's only 1 girl left. So that covers the number of ways the girls can go through. Now I'm going to do the same thing for the boys. Well, there are 4 boys total, so one of 4 of them will walk through first. Then of the 3 remaining, 1 will walk through. Then there's 2 left, and then finally that last person would walk through. And so now I have basically 4 factorial twice. Or if I take 4 times 3 times 2 times 1, multiply it by 2, there are 48 ways that the girls can walk through and then the boys follow. Alright, and you see kind of the little slash idea, how I said how it goes 8, 7, 6, 5, 4, 3, all the way down. Kind of like the license plate question. Alright, for the next problem, it's going to ask us to find the number of distinguishable permutations. Like I said, how many ways can I rearrange the letters in that word to get another word? But when I say another word, I don't mean a word that makes sense. So for example, could I take these 2 letters and switch them around? Absolutely. It's not going to make sense, but it would give me something different. Now, where I have to be careful is what happens if I just took these 2 and switched them? I would have the exact same word, so that's where the distinguishable comes in. It's saying that, oh, you got the same word, so you can't count that. So, if you remember what to do, you want to count the total number of letters that you have here. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I've got 10 total. And then what you're supposed to do is you're supposed to look to see, okay, how many of these things are actually repeating. So how many S's do I have? I've got 1, 2, 3 S's. How many T's do I have? I have 1, 2, 3 T's. How many A's do I have? I have just one of those. Whoops. How many, I've already done the T's. How many I's do I have? It looks like I have 2 I's. How many C's do I have? I have one of those. And we've already done the S's, and then I guess what I would do is I would just add these up to make sure that you get to 10. 6, 7, 8, 9, 10. Yep, so I've got all of them. Alright, so the idea is this. The number of distinguishable permutations will be the total number of letters that you have, so 10 factorial in the numerator, divided by, and then it's the number of times that you repeat factorial. So I have 3 S's, so this would be 3 factorial. It's the number of ways that I could take these 3 S's, change them around, but end up with the exact same thing. So that takes care of the S's. I also have 3 T's. I have 1 A, so I can put 1 factorial, that's just 1, so I don't need to. And then I have 2 I's. And now I just need to figure this out. And so I can't multiply these numbers together and then take the factorial of that. I need to figure out these factorials separately and then multiply them all together. So it's basically a calculator problem. So you're going to go ahead and type in 10 factorial. And looks like your numerator is 3628800. So 3,628,800 ways to rearrange those letters. Now because some of them repeat, I know 3 factorial is 3 times 2 times 1, which is 6. Same thing for that one. And 2 is just 2 times 1. So I'm going to divide by, now I can hit divide by 6, enter, divide by 6, enter, divide by 2, enter. What I don't want to do is I don't want to say 6 times 6 times 2 and hit enter unless I put parentheses around it, because again, your calculator is very sensitive with the order of operations and it'll end up giving the wrong answer if you aren't careful. So the number of ways that I can rearrange the letters in the word statistics so that they will give me something different, I can do that 50,400 ways. Alright, we are on to the third problem. Toy manufacturer interviews 8 people. 3 of the 8 are women, so 3 are women, which means 5 are men. If all 8 are qualified, so we're not restricting anyone for any reason, how many ways can the employer fill the 4 positions? And it says the selection is completely random. So, if I have a completely random sample and I want to pick 4, and I want to know how many of those 4 can I get, you have to ask yourself the question, does it make a difference or not whether does it make a difference? Let me say it again. Is the order important? I knew I'd eventually get it there. Is the order important? Meaning, does it matter if I pick person A, person B, person C, and then person D in that specific order? So if I picked person A, B, C, and D, well, what if I had picked B, D, A, and C? It doesn't say anything in there about one person being more important necessarily than the other. So that's kind of telling me that I should probably be using a combination here, because it doesn't mention anything about the number of ways or who's going to be more important than the other. So I'm going to use a combination. And when I look at this, there are 8 people total to pick from. I want 4 of them. And so I'm going to go ahead and type in my calculator. 8 math, go over to PRB, combination 4, hit enter, and it tells me that there are 70 ways that this can happen. So if I wanted to just randomly pick 4 people, I can have 70 different groupings. Alright, now it says over here that I want exactly 2 to be women. And then picking 4, so that means 2 of them have to be men. Well, if I want exactly 2 women, ask yourself the question, how many women are there? There are 3 of them. I want to pick 2 of them. Order doesn't matter. Again, it's not saying the first woman I pick is the president, the second woman I pick is the vice president. Then the order would matter. Then I would use a permutation. This will cover the number of ways I can pick the women. I still need to cover the number of ways I pick the men. Well, there are 5 men, and I need 2 of those also. And so I'm just going to multiply these 2 together, because that's my counting principle. So 3C2, I hit 3, math. Go over to my combination button, pick 2. You might remember the little Pascal's triangle trick that we used to help us figure out that that was 3. 5C2, go to 5, math, over to, and looks like it's 10. And I multiply those 2 numbers together. And if I have to pick 2 women and 2 men, there are only 30 ways for that to happen. So notice the difference between the two. And big thing, notice why we're using a combination, because order is not important. Alright, and then for this last one, solving for n, it's a permutation, so I want to use this formula. And so if I look over here, this is standing for the n. This is standing for that numerator when you usually have your formula, which is npr is equal to. So it should be n minus 2 factorial. I don't know what the exact number is, but that's okay. Divided by, it would be the number n minus 2 minus r. So this would be n minus 2 minus 4 factorial is equal to 4 times, and now same thing here, this would be my n, so this would be n minus 3 factorial. I don't know what n minus 3 is, so I'm just going to have to leave it as a quantity like this. And then it's going to be n minus 3 minus 2 factorial. And like we mentioned in class, or if you didn't remember, when you have something inside parentheses or a bracket with a factorial, it's like an absolute value. You need to simplify this as much as possible before you apply the factorials. So over here on the left side, I've got n minus 2 factorial. Just going to leave that alone for right now. The denominator, if I simplify that, that would be n minus 6 factorial is equal to 4 times, my numerator is n minus 3 factorial, and my denominator is eventually going to be n minus 5 factorial. And now just think of what the definition of factorial is. For example, if I want to know what 4 factorial is, I start with that number and I keep multiplying until I eventually get to 1. Well, I'm going to use that idea. N minus 2 factorial, I would start with that number, n minus 2. Then I would subtract 1, which would give me n minus 3. Then n minus 4, n minus 5. Of course, the problem is I have no idea when I'm going to get to 1. So I'm basically not going to write them all out. I'll just say it's going to continue to do something like that until eventually I get to 1. So let's just do that. Well, denominator, same thing. I have n minus 6 is what I would start with. Then I would subtract 1 to get n minus 7, and eventually I'm going to get to 1. And what do you hopefully notice? Everything from n minus 6 on down, even though I don't know when I get to 1, all that stuff is going to cancel. Is equal to, now let's do the same thing on the right side. If I look at the numerator, it's n minus 3 is where I would start, then n minus 4, n minus 5, and so on. I can see that n minus 5 is where I would start in the denominator, so there's no need to write out a lot of these. In the denominator, I've got n minus 5, n minus 6 if I subtract 1, and eventually I get down to 1. And of course, everything from n minus 5 on down is going to cancel. So really, what am I left with? I'm left with n minus 2 times n minus 3 times n minus 4 times n minus 5 on the left side is equal to 4 times, on the right side, it's just n minus 3 and n minus 4. So it simplifies somewhat nicely. And now if I look at the right and left side, they both have an n minus 3 and an n minus 4 in common. I can just divide both sides by that. So I'm left with, if I distribute on the left side, n squared minus 7n plus 10 is equal to 4. Now my instincts are telling me to multiply that out because it equals 4, and if I'm solving an equation with a square in it, I know I need to set it equal to 0. So I multiplied it out so I can combine like terms. And I get n squared minus 7n if I subtract the 4 plus 6 is equal to 0, and now I'll go ahead and just factor. This is going to give me n minus 6 and n minus 1, and if I set both of those equal to 0, I get two answers. I get n equals 1 and n equals 6. And if this was a problem that was on the test, and say you had 5 minutes to spare, you can easily plug those numbers in to see if they're going to work or not. Now, in terms of this particular problem, let's say I plug 6 in here. Well, I'm going to get 4, so I would have 4p4 is equal to 4 times, if I plug 6 in here, it's 3p2. And I'm not going to run through and show you that it works. It actually does work. If you think about, it does work. You can do that if you want to. The reason I'm doing that is, okay, let's say I plug 1 in here. So it's not that I necessarily need to check the answer to make sure that they work. If I've done the algebra, they will. But watch what happens when I plug a 1 in here. If I plug 1 in here, I'm going to get negative 1. remember, we can't have anything negative on the left side because by definition, when I start at -1, I would then drop to -2, -3, -4, -5. I'm never going to get to 1. So the answer of 1 actually doesn't work. It's just 6. So now, assuming I do all this correctly, my algebra is right, I don't need to physically plug 6 in here and then evaluate it to see if the two sides equal each other. They will, assuming I did my problem correctly. All I need to do is make sure that this left side is not a negative number. Alright, that is your homework help for section 9.6.